Satlas is a platform for exploring global geospatial data generated by computer vision models from satellite imagery. I'm Fabian, and this video will demo the Satlas website, which you can access at satlas.allen.ai. I'll also discuss how foundation models trained on our large-scale remote sensing dataset called SatlasPretrain were key to building the models used to generate the geospatial data in Satlas. In Satlas, we've openly released global data for various kinds of geospatial information, including the positions of offshore platforms and wind turbines, the positions of solar farms and onshore wind turbines, as well as global tree cover canopy percentages. All of this data is updated on a monthly basis by downloading new satellite images covering Earth's entire landmass every month and processing those images through computer vision models. Key to Satlas is the accuracy of our computer vision models. These models are pre-trained on a large-scale remote sensing dataset that we built called SatlasPretrain. SatlasPretrain is huge. It has over 30 terabytes of satellite and aerial imagery that's paired with over 300 million labels across 137 categories. We've released foundation models trained on SatlasPretrain for 3 types of satellite imagery: Sentinel-1, Sentinel-2, and Landsat, as well as high-resolution aerial imagery from the U.S. National Agriculture Imagery Program. Overall, we found that pre-training on SatlasPretrain improves average performance across 7 downstream tasks by 6% over the next best baseline. Going back to the models in Satlas, so we take the foundation models pre-trained on SatlasPretrain and fine-tune them on very high-quality hand-labeled datasets to get high-accuracy models for detecting solar farms, wind turbines, offshore platforms, and tree cover. The data computed monthly by these models can be visualized in the Satlas website. So let's say that we're interested in finding recently constructed solar farms near Paris. We can select renewable energy, deselect wind turbines, and let's zoom in on Paris. And then to identify recently constructed solar farms, we'll use this change over time view, which allows us to specify 2 timestamps, and solar farms constructed during this time range will be shown in green, while pre-existing solar farms will be gray. So it looks like there's a recently built solar farm just a bit southwest of Paris. We can go back to single map view and turn on satellite imagery. It looks like there's a solar farm here as of the end of 2022, but it's a bit hard to tell what's going on because this frequently available satellite imagery that we're using, namely Sentinel-2 images from the European Space Agency, are quite low resolution. And that's also why SatlasPretrain is so important for developing models for the challenging task of identifying objects in these images, because they're so low resolution. Anyway, if we go back to 2020, we see the area was undeveloped at that time, but it looks like in the beginning of 2021 it was cleared for construction, and by the end of 2021 the solar panels were installed. To double check that this is in fact a solar farm, we can try to cross-reference with higher resolution imagery in, say, Google Maps. So we plug in the coordinates of this solar farm into Google Maps, but this image is actually outdated. It doesn't correspond to the latest view that we saw from Sentinel-2. Instead, it seems to be closer to the beginning of 2021, so that's over 2 years out of date. And that's a common problem with high-resolution imagery outside of dense urban areas. It's often years out of date. This brings us to another feature in Satlas, super resolution. We've trained models that can take 10 to 20 low-resolution Sentinel-2 images of a given location and synthesize information across those images to produce a 4x super resolved image. Here's an example in Kenya, and here's another example in Australia. What this means is we can go back to our solar farm and turn on super resolution at this location, and oh yeah, we see it does in fact seem to be a solar farm. Now, super resolution isn't going to be perfectly accurate, but it's trained independently from the rest of the Satlas models, so it's another signal about what is present at a location like this. Lastly, I just want to note that in addition to visualizing the geospatial data in the Satlas website, you can also download all of this data for offline analysis. So yeah, to conclude, please check out Satlas at satlas.allen.ai or see our ICCV paper for more information about SatlasPretrain. Thanks.